Teaching and Learning at the School of Education and Human Development. Previously, as a fellow instructional designer, I appreciate that he has instructional design experience. He developed and evaluated more than 30 online and offline courses for adult education. He also ran a company for training new employees, either from government agencies, commercial enterprises, as well as nonprofit organizations. His main research interests focus on learning technology design. That includes educational games, gamification, scaffolding, educational robots, augmented reality, as well as artificial intelligence. From learners ranging from preschoolers to adults. Of course, a variety of different particular educational fields, right? From STEM to special education. You can find his publications widely in top-tier academic journals related to instructional technology and learning sciences. We're so grateful for you to speak at our EdTech Cafe, Dr. Kim. This is going to be a continuously ongoing monthly event where we hope to invite other experts. I know we have some PhD students, maybe share some of your research in learning science and learning technology. Has any relevance in those subjects? We'd love to hear from you and have this discussion. This is a nice venue. So thank you, Dr. Kim, and without further ado.
Thank you so much. Thank you so much. Hi everyone, thanks for being here. So, as he mentioned, I was a former instructional designer technologist. Whenever I have a chance to meet new people and introduce myself, I always get this question. Hey, Dr. Kim, how can I make my child study well? Wow, this is not an easy question to answer, but I strongly believe that it's a great way, problem-based learning, I think. So now today, I'm gonna talk about the problem-based learning and explain about how we make this problem-based learning as effective the instructional model. Oh my God. Oh my God. Okay. Problem-based learning first developed and implemented in medical school in Canada in 1960s. And this problem-based learning has been expanded into undergraduate coursework as well. And now this problem-based learning has been used in K-12 education as well, specifically in STEM area. Why? Because problem-based learning is really, really unique in terms of task. First of all, in problem-based learning, students were asked to solve these ill structures and authentic problems. What is ill structures? There is no one single right answer or wrong answer. And the authentic problem means this kind of given task should be related to the learner's real world situation, their real life. In problem-based learning, students should have a responsibility for their learning. For example, they should searching for any information and use information and evaluate and validate in the collected information by themselves. And then based on this, they create their own solving. So, yes, but throughout many studies, so this effectiveness of problem-based learning has been demonstrated in terms of self-directed learning skills and several types of higher order thinking skills, including critical thinking, creative thinking, or problem-solving skills. And even the problem-based learning can improve learners' collaborative learning skills. This is one simple real samples used in the problem-based learning. So please read this. So this is I just create this kind of task, a structured task. So save our Logan city. Logan is located in the Utah state. I graduated Utah state, so I use this Logan city. So Susie was shocked to read a newspaper article that pointed out that Logan, Utah is 10th worst city in terms of air quality in US. Can you believe this? This is real. This is real. Yeah. So since Logan is a rural area, she questions whether this article is correct or not. So therefore, she decided to try to find the reason of the bad air quality of Logan City and compare it to other big cities with notorious bad air quality. How can Susie find the reason why the air quality in Logan City is so bad? If students want to solve these kinds of air quality issues, they should know about the sub-components of air quality. That means they already know about the specific content-specific knowledge about air quality. And then they need to collect much information about air quality across all cities. So that means this kind of ill structures or authentic problem require students more advanced in the problem-solving skills. But there are so many issues in problem-based learning, specifically this in terms of three things. First of all, this problem-based learning requires really complicated process. To solve, I already mentioned that, to solve ill structures authentic problem, students need more advanced in the problem-solving skills, metacognitions, and deep understanding of the contents. Wow. And another issue is that lack of qualified facilitators. In our traditional classrooms, or traditional teacher-led instructions, first of all, teacher provides some kinds of information, or teacher teaching so many things, many things about the content-specific knowledge. And then based on this, teacher just solve a certain kinds of multiple choice problems or anything else. But in case of problem-based learning, teacher should play a role as facilitators. What's the role of facilitators? First of all, help students recognize the problematic situation by themselves. So teacher should guide students to recognize this. Second, facilitator should simulate students advance the thinking processes and knowledge integration skills. Third, facilitator should inform the learning process and induce the evaluation of the group members' opinion and work through the active interactions. But think about that. Our current teacher can do this without any specific introductions in lessons? I don't think so, because this is really, really difficult for our current teacher to do this. So now some institutions have some kinds of section for professional development, for just cultivating this kind of facilitators in the problem-based learning, in case-based learning, and project-based learning, but not enough. Specifically in Florida, I don't think so. So this is a really big issue, the lack of qualified facilitators. Third issue, self-directed learning skills. Our K-12 students or adults, learners, already familiar with teacher-led instruction, traditional classrooms, right? When, for example, K-12 students who are familiar with the learning objectives and the plan decided by teacher, first of all, they just try to do this problem-based learning. Chaos. What should I do? What should we do like this? They don't have any answer about this. So that is the reason why problem-based learning has been recognized really effective instructional model, but in real our classrooms, everyone said, oh, I don't think so. Really, true. Because of these kind of issues, students cannot perceive the optimal challenge in problem-based learning. Why we consider optimal challenge in problem-based learning? If students perceive the optimal challenge, student can be in the flow state. The flow state is the kinds of psychological states and characteristic by energized focus and full involvement and then enjoyment in the process of activities. If students perceive optimal challenge and they're in the flow state, it might be huge possibility of success in their learning, I think. what the precondition for this flow state? First, clear goal. Second, immediate feedback. Third, optimal challenge. I already mentioned this, optimal challenge. But optimal challenge means tasks are either too difficult or too easy for student current ability. Wow. How can student be encouraged to perceive optimal challenge? This is really important. We have two options. Teacher can provide tasks with diverse difficulty level according to student current status, right? Oh, you're top level. I give you really, really difficult, most difficult task to you. Oh, you are a little bit low performers. Also, I can give you easier test to you. But is a possibility in the real classrooms? We have more than 20 or 30 students in our class. So how teacher provide the different level of task to individual student? This is impossible, almost impossible, I think. So another way, another option is to allow students to recognize the given task as doable, right? Even though we have one difficulty level of task, but we just allow students to recognize this given task as doable, right? Satisfy the student current needs and difficulties for problem solving. How? Using scaffolding. Scaffolding originally defined as support to help students to carry out the given task. But this task normally beyond their current ability. Okay, this is, I suggest, the one learner-centered scaffolding systems in the problem-based learning. Looks like a little bit complicated, right? So I explained specifically the components of this, within these systems, I think. Did you remember, I mentioned that there are three types of student difficulties problem-based learning. First is a complicated process. So due to this kind of complicated process, students have some kinds of learning issues in terms of conceptual and metacognitive, or procedures, or strategic issues, I think. So this scaffolding can satisfy this kind of four different type of issues, for example. It can be solved, right? So we think about that. Okay, scaffolding can be provided. Okay, or teachers or other resources can be provided to these different four type of scaffolding to solve these complicated process issues, I think. What is the conceptual scaffolding? Simply, this scaffolding play a role in address the issue in understanding content-specific knowledge. Think of that. Metacognitive scaffold can be provide a certain kind of support for students to reflect their own learning process, I think. Strategic scaffold that suggests the process to solve the problems and provide a guidance about the problem-solving strategies. And motivational scaffold is to relate to their motivations. But two things, conceptual scaffold and strategic scaffold is a little bit confused because the role is really, really similar. But to clear understanding, in the case of conceptual scaffolding, provide certain kinds of concept map, for example, to understand the concept. What we need to learn, about what we need to learn. But in the case of strategic scaffold, provide a certain kinds of strategy about how to solve the problems. So what and how. So these two scaffolding play a different role, I think. So if this scaffolding handle concept issue, metacognitive issues, strategic issues, the motivational issues, I believe this kind of study can just address this kind of complicated process in the problem-based learning. In the case of lack of qualified facilitators issues, now I think about the computers use, I think. Okay, why always teacher provide the scaffolding? now computers has been advanced. So computer system also provide this kind of systems, this kind of scaffolding, I think. But how? I think this is a really sensitive issues. Computer systems can just monitoring to the current in the learning paces or their status, and then can immediately give the feedback systemically based on fixed time interval and student performance, I think. And teachers can provide the more individualized and sophisticated scaffolding to students. And we can combine this. How? We can consider the advantage or limitation of these two types of scaffolding sources. In the case of teachers, scaffolding, not feasible for one teacher to provide immediate feedback to every student, right? But in the case of computer-based scaffolding, only provide the really, really simple support. You're right. You're wrong. You're right. You're wrong. Or like this, for example. But look at this. This kind of undifferentiated in the simple help is written by the Jonathan and Liv in 1996. Old-fashioned. Old-fashioned. Now think about it. Now current status of technology. Improved a lot. So I think about the combination of sources of scaffolding. So I just already mentioned that four type of scaffolding can be delivered by two scaffolding resources. One is computer-based scaffolding, and another is teacher-based scaffolding. So one thing is that how I can combine these two different type of scaffolding sources, I think. So first of all, computer-based scaffolding recognizes the step and presenting the just-in-time scaffolding framework. Okay, and then next, if student cannot satisfied with the computer-based scaffolding, they immediately ask teacher for further support. In this case, the teacher can provide individualized and sophisticated feedback to identify whether students follow correctly the scaffolding framework. Please forget this here. What this kind of combinations of these kind of two resources is effective? Because first of all, computer handle all kinds of student issues first. And then in this case, some students already just address their current issues, right, with its computer-based scaffolding. And remaining issues, teacher can test the remaining issues. What's the benefit of this? In this case, this kind of combination system can reduce teachers' workload a lot, because teacher only handle some students, I think. And lack of the self-directed learning skills. So think about it, how we can just improve the self-directed learning skills. Wow, I just spent tons of time to just design things. So they already got tons of scaffolding from computers or teachers, I think. So if students can decide keep receiving this kind of scaffolding or not, based on their current status, because they should monitoring their own learning pace by themselves, and then they can decide. We just call it the fading. Scaffolding fading is the reduced in the scaffolding like this. If the student decide this kind of timing of fading of scaffolding, I think that process can improve the student self-directed learning skills, I believe that. So, first of all, in the case of fading, suitable time of fading for optimal challenge, I think. So, who decides this fading? First of all, by computers, teachers, students. We have three options. Computer can keep monitoring their learning status, and then stop giving the scaffolding because this is not enough. Already just solved these issues, so we can stop. Computer can decide this. Teacher also can't monitoring their student learning status. Okay, and then stopped giving any scaffold. Student can decide this kind of the scaffolding provisions by themselves. But we only focus on student decisions, I think. So enhancing self-confidence and motivation through self-selective fading, I think. So self-selective fading may be a good option for optimal challenge. We believe this. So, as you can see, this is initial scaffolding. But initial scaffolding consists of 4 types of scaffolding to handle different type of student learning difficulties. And then, first of all, this scaffolding can be provided by computers and next by teachers. And if students keep wanting to get into this scaffolding, and computer system adding this 4 types of scaffolding continuously, and then next, even though I just keep receiving this kind of scaffolding by computers, I cannot solve these issues. Teacher, I need your help. In this case, teacher add specific scaffolding. And self-selective fading. Student can decide in this fading and timing. And then computer and teacher verify this time or decision, student decisions. This is just I called learner-centered scaffolding systems. This is my real application of this learner-centered scaffolding system in problem-based learning. As I mentioned that this is a real task, save our Logan city. And then I developed this real virtual field trip software. I call this is an online version of a problem-based learning, I think. So, first of all, students can walk around in all kinds of US cities. They select the cities. And then gathering the real-time air quality data using the platform from the Google Street. You can see that this is a Google Street View. I developed this kind of systems in the 2016. So the graphic has low quality. But anyway, so okay, this is a real street, and then students can just walk around these real cities, and then if they just decide the measure air quality at the point, they just push this measuring button, and then the system can automatically connect to the air quality government air quality website, and then they just send the real-time air quality measurement to this software, and then student can see the real-time air quality data, I think. And then they can select the multiple cities, and then they compare in the component to influence the air quality between the cities. And then if they want, they can directly go to the Google, and then they can search for any data about any information about air quality, and then they just learn about air quality by themselves. And then I also include some kinds of collaboration function in here. So they just make a certain kinds of group, and then in the between group they just have some conversation about what solution is best, and then your solution is best, and then we can just select your solution as our group decisions are like this. Anyway, so this is the background of this software, and this is the most important thing is that I embed my scaffolding system into this virtual field trip software. It took 6 years to develop these scaffolding systems. This scaffolding system based on artificial intelligence. So I used machine learning algorithms to develop these artificial intelligence-based scaffolding systems. I collect around 13,000 cases from literatures, and then I just collect in the longitudinal data with 300 students for 5 years. And then I just create certain kinds of specific example of effective teaching support. That means we just observed all teachers' behavior and activities. And then we let computer know about this kind of real example from teachers. And then, as I mentioned, that I just utilize the machine learning algorithms. This is the popular algorithm for artificial intelligence nowadays. So, my scaffolding system names is Popo. So, just walking around these cities and they need help, just call Popo. Popo, I need help. In this case, my intelligence system wake up, and then this AI system can help any students. So, as I mentioned that this AI system, AI-based the scaffolding system, provide two support. First support is generic support, like Siri and Alexa, like this. And the second, specifically support for learning. So as I mentioned that this kind of AI system can provide four types of support: conceptual, strategic, metacognitive, and motivational scaffolding. As I mentioned, first of all, students just walking around these cities and measuring air quality. And they have so many questions. And first of all, ask this Popo. And then after that, students cannot satisfy the Popo support, they just raise your hand to ask teachers support. But in my the research, there is nothing. There's nothing to ask teachers direct support, I think. So now I demonstrate this real AI-based scaffolding systems. This is a generic support. So first of all, this is the first initial page for selecting any cities to just measure air quality. So there are so many, but at this moment, so I have, there is a limited number of cities students can select, because this is a personal research project, so I don't have enough money to just include all cities in US. So I just include in the 15 cities or 16 cities like this. So, okay, I demonstrate this.
Good morning, Namju. Weather is nice today, so we can really enjoy our time to measure air quality. But please do not choose California. Currently, it's raining there.
You know what I'm saying?
Good morning, Namju.
Sorry, yeah. How I can, just, sorry. AI system already searching for any information about weather. So if students select in the California, any cities in the California, it might be really difficult to just measure accurate the air quality. So first of all, this AI system not recommend to go to any cities in California. Oh.
Good morning, Namju. Weather is nice today, so we can really enjoy our time to measure air quality. But please do not choose California. Currently, it's raining there.
Oh, I'd like to go to San Francisco.
This is almost a 100%
So sorry,
in the
because
voice
it might be
recognition algorithm.
impossible to measure air quality accurately when it rains.
Okay, I want to choose Chicago.
And then I just choose Chicago instead of San Francisco based on the AI's recommendation. Oh, like this. And this virtual filter is developed based on the Google Street View. And then click. When I just point out a certain field, they shows the real street views here, like this. And then another example is to like a general support, the personal data. So I allow the computer to access all my account, Google account or Gmail account or all kinds of email account or all kinds of accounts. So this AI system already know about me, everything. So look at this. I choose Chicago, right? So I work
Namju, you selected Lower Wacker Street in Chicago. Did you remember this street? You visited here in 2015 for attending a ERA conference.
They know about.
Oh, you're right. Could you let me know the list of the restaurants I visited at the time?
And then searching on my data.
Sure, in my record, you visited Chicago Cut Steakhouse, Coco Pazzo, Daebak Korean Barbecue, Cafe Baba Reba, Burger King twice.
Thank you, Bobo.
Interesting, right? So, and then this is a generic support like this, and then this example is for the showing the specific the support for learning.
Hey, Bobo. I heard CO2, NO2, and PM2.5 before, so these things indicate air quality.
Air quality can be determined by the several levels of pollutants, and you need to check these pollutants, which have a huge impact on the city you selected. Please visit this website, www.airnow.gov, to learn air quality components.
What I think about that is really, really effective, right? To provide any internet resources to learn more about air quality. Because everyone just asks me, when I just present this kind of my software in front of an audience at the conference, they ask me, how AI know about these kind of specific resources about the air quality? I just mentioned that. Think about it, considering our pre-programming, for example, skills. This is not impossible, I think. This is not possible, because in this case, we should pre-programming all kinds of resources. But I just adapt the machine learning algorithms. So that means computer system learn something by themselves after just building initial model. So, because if you just go to the Google website and then, for example, air quality, you should put the air quality here. So Google itself, the evaluate in the website, in the validity or the accuracy like this. So based on this information, Google recommend choose one of the most validated in the website about air quality, and then suggest and recommend to go to there like this. And then in my programming, so I just let computer know about .gov or .edu can be most validated in the website or resources, because this kind of .gov is a government website or EDU is the Education Institute website. So first of all, I just make the priority. So that this kind of website is the more believable. So please recommend first this kind of website like this. So that is the reason why this, but airnow.com like this, for example. But everyone just said airnow.com is the most believable website about air quality components like this. So this computer system also know about this airnow.com is the validated in the website. So that is the reason why Bobo recommend this website resources. And then this is another example. I'm just walking around in this city and then look around and then just decide to measure air quality at this point.
Okay, I want to measure air
Measure
quality here. Push this measure button. Oh, two tools.
Two tools. I have two
Hey,
tools.
Bobo, which tool should I use? What's the difference between these two?
As you understand, the components of air quality are diverse. On the screen, you can see two types of tools to measure air quality.
AI control this.
Unfortunately, there is no tool to estimate all kinds of components. One is for chemical components, and another is for physical components. For the accurate measurement, you should choose the proper tool. First of all, you need to know whether a certain component you try to measure is chemical or physical.
Thank you, Bobo.
This is a procedural support for the learning. Another example, metacognitive support.
Okay, this is my last measurement. CO2 is 3.5,
This is a real-
NO2
real
70,
time data
ozone
about the-
0.9,
air quality
SO2 is 1. PM 2.5 is 39, PM 10 is 153. Gotcha. Okay, I finished to measure air quality. Hey Bobo, what should I do next?
According to API history, there is a huge wave in the level of air pollutants in a city you chose. Can you find any information about this and explain the reason of a huge wave?
Like this. So this kind of AI system can just provide a certain kind of support to allow the student to reflect their finding, I think. This really leads to their student metacognition skills, I think. So this computer system can provide this kind of system because this system already know about the history of air quality in cities I choose, I think. And then next.
Okay, this is my
next item. This is also interesting functions. What is the limitation of online learning of test behavior? Because they just open the new tab in Amazon or YouTube like this. So a teacher cannot capture this because your monitor, I'm teacher, but I cannot see your monitors, right? So, but this system can monitor student of task behavior. Walking around, and I open new tab and put the Amazon.com. And then this AI system keep monitoring my history, and then they just hit AI system waiting for just a 15
Why do
seconds.
you keep accessing to www.amazon.com, which is not related to your learning? If you visit another site once more, I will report it to your teacher.
so sorry. I will never do this again. Never.
Interesting. This is another function for the motivational support for learning. But as I mentioned, that this is the draft version. This is not the complete version. So I keep developing this kind of system. So this is a motivational support.
You are a little bit behind your team members. 2 students in your groups have already finished their measurement. However, it does not matter how long it takes as long as you measure air quality accurately. Cheer up.
How could they finish to measure air quality so quickly?
I don't know. Maybe they are smarter than you.
This is error. This is error.
That is not a
Because
good answer.
I didn't pre-programming everything, right? But so this AI system searching for any responses if I ask this kind of question, but she just collected the wrong information. So that is the reason why she just responded to this wrong answer. They are smarter than you, like this. But after that, I just mentioned how Popo there is not right answer like this, and then Popo just recognized this. Oh, this is not good answer. So this kind of AI system learn one more thing, right? And then later, this AI system never tell this kind of smarter than you again, never. Okay, this is a machine learning algorithm space, the artificial intelligence based in the scaffolding system. So like this, for example, this is not perfect. And then I don't believe this kind of AI-based scaffolding system cannot place in the teacher's wall, 100%. But if this AI system can support teachers, wow, teachers can reduce their working load a lot, I think. And then, in this case, teacher can provide individualized support to small scale of students, I think. I can see the benefit of this kind of computer-based scaffolding within these kind of situations. And soon I will also add some functions of this scaffolding to evaluate student performance as well, using their iris movement or their facial expressions or other things. So I think nearly futures, I will just complete the development of this AI-based scaffolding system, and then hopefully I adapt this AI-based scaffolding system into our Blackboard systems as well. So in this case, this AI system can predict student success or fail after just 1 week. So I'm saying this is a really innovative. After spending 1 week, this AI system can predict this a certain student success and failure. And if this kind of system can recognize this kind of issues and can report directly to instructors. And this AI think, oh, this student have some kinds of psychological issues. And then this system can report this issue to counseling office, not to instructor. So I think this utilization of this AI based in the scaffolding systems is unlimited, I think. So we keep considering the utilization of this AI system in the future, I think. And specifically in online learning PBL, because I just mentioned about the benefit of problem-based learning. So I keep trying to just adapt this scaffolding system into learner-centered instruction model, including problem-based learning. Okay, thank you so much. Yep. So any questions? So yeah, if you need further information about this my system, so please visit, please just searching for my current published article